From the previous video, we're now equipped with knowledge about how we can use array formulas with ordinary functions such as f. We will use this knowledge in this following exercise, in which we have the coordinates of 10 cities. The x and y coordinates, so let's give names, formulas, create from selection, top row. And we want to build some kind of a road network that traverses those cities. But let us not be very specific about our final goal at the beginning. Let's rather leave it for the end. But the first thing we want to do is now get the x and y coordinates of those 10 cities according to these numbers up here. We could use functions such as transpose that we've recently studied, but let us not do that. Let's use another function. When we think of it, if we want to get the x coordinate of city number 1 to cell F1, what we need is an index, and we take with index the first x coordinate. Let's write it down. Equals index, parenthesis, the array name is x, semicolon, and the first is indicated by F3, which is the city number, F3. Okay. We need the similar thing for y coordinates, so it's index, y, F3, and we get the x and y coordinates respectively for that city. Let's copy these two formulas so that we'll get the x and y coordinates for all the cities. Okay, and now we see on the graph they are all marked. Now, what interests us next is the distance between two cities. Let's say, and let us just explicitly mark this down here as well. Let's say that we're interested in city with coordinates. Well, it seems to be something like 2105. Yeah, 2105 is its coordinate. And the other coordinate, the other city we're interested in, has coordinates 597. This is the city right here. So 2105 and 597. Now, what interests us more specifically is the distance between these two cities. So what we need to do here is we need to build up one such, as it's called, right triangle. So here comes one side, one side of the right triangle, and here comes the other side of the right triangle. Here it is. Okay, and now from these two we need to calculate the straight distance between the two cities. So let's take a straight line and let's draw them between these two. So once again, we are interested in measuring the straight distance between these two cities. For that, we take 20 and 5, which are the x coordinates. We subtract 20 minus 5 equals 15. So this here, one side of the right triangle is 15. Furthermore, we take 105 and 97, subtract 105 minus 97 equals 8, and we get the other side of the right triangle. So 15 and 8, and now what we need to do is we need to use those 15 and 8 right equals 15 to the power of 2 plus 8 to the power 2 and here it is. This is 289. And take square root from it. That's SQRT. Square root of 15 squared plus 8 squared equals 17. And 17 is the distance between these two cities. We've used the Pythagorean theorem, and we've calculated the difference of x's, the difference of y's, used those as the two sides of the right triangle, and calculated the hypotenuse of the right triangle from Pythagorean theorem. Okay, let's now